question is find the equivalent resistance between the A and B. Now we can identify the node. So this large node here are the equivalent potential. We can denote this as C node. And then here we have this node is denoted as the D node. And then this one is denoted as the B node here. Okay, we can redraw the circuit here. Simplify this circuit. We'll redraw this. So now we have start from, let's say this is our node A. Go to R1. This is the R1. Now this R1 is go to this C node here. This C node is going to split how many paths? Well, you can see here how many paths is split. You see C node is 1, 2, and then 3, 4, 5. So we got 5 branches from C node. Okay, we got 5 branches. So here we're going to draw the 5 branches. So 1, 2, 3, 4, 5 branches here. Then we're going to label it the value. We start from the top one, which we label this as R3, followed by R4, and then we have R6, and then we have R2, followed by R7. Okay. Now from the R3 to R4, they connected to D node, right? So these ones will be connected to the D node here. This is what we call as a D node. Okay, so on this D node here, after connect to D node, then we connect to the R5. So here we have this R5 here, R5. So the N terminal of R5 is the V node, right? It's the V node. So that means this is our V node here. Okay, so all the R6 is go to the V node, R4, R2 go to the V node, R7 go to the V node. So that means all these 3 is connected to the end of the V node. Okay. Now we're going to put in the value for this. So R3 we have 8 ohm, R4 is 4 ohm, R6 is 8 ohm, and R2 is 4 ohms, R7 is 2 ohm, R5 is 6 ohm, and R1 is 2 ohm. Okay, so now we're going to find the this equivalent resistance, this network, C network here. We're going to find this. Okay, this can be considered as once a network. So let's assume that this equivalent resistance RC network is equal to R5 plus R3 parallel with R4. Okay, so this is one network. So here we have R5 is 6 ohm plus R3 is 8 ohm parallel with 4. Okay, so from this you do the calculations, you get this value, which is 104 divided by 12. Okay, so this is RC. Now we can find immediately the IEQ between the point A and point B, whereby there are branches. Okay, there's a branches. We start from this R1 here. Now R1 is in parallel with all these 4 branches. This one, this one, this one, and this RC network here. So they are in parallel, right? So that means we can write here, whereby this RC now is in parallel with R6, parallel with R2, parallel with R7. Okay, so how to find this? We substitute the value. R1 is 2 ohm. Then we're going to find the equivalent resistance. So RC we get is the 104 divided by 12. So we get one's inverse of this 1 over RC, 1 over RC plus 1 over R6 plus 1 over R2 plus 1 over R7, and then we take the inverse of it. So in this case we have 2 plus, so 1 over RC inverse, you get 12, 104. Here is 1 over R6, R6 is 8, then R2 is 4, then R7 is 2, then we get the inverse of this. Okay, then we're going to calculate this, where we have 12, 104 here we get 8, and total up here we have 7, and then we take the inverse of this. Okay, so from this we have 2 plus, so we can equal the numerator, we get 104, so it's 12. Okay, these ones we're going to get 91, and then we get the inverse of this. Okay, so at the end you have a 2 plus 1.009, so the value is 3.009 ohm. So this is our REQ value.